This is a worked example on how to find the value of a trig function that's not on the unit circle. And this time we'll be taking advantage of the half angle formulas. So in another video, we looked at a way that we could use the sum and difference identities. And this time, we will be taking advantage of the fact that we can rewrite this as a division by 2 of an angle that is on the unit circle. So it's easier to find out what angle we're using here because it has to be a division by 2. That's how the formulas work. And so if I take pi over 12 and I factor out a 1/2, you end up getting that pi over 6 over 2 is equal to pi over 12. If you're not familiar with how this formula works, it's because pi over 6 times 1/2. You can kind of put this into the numerator in the multiplication, and pi over 6 over 2 also equals pi over 12 if you multiply across denominators. That, you can take my word on this. I assure you this is correct. Okay. So now we're asking about sine over pi over 6 over 2. And the angle identity we're going to want to use is the half angle formula for sine. And I will write that out really briefly. That's going to be sine excuse me, of theta over 2. That is equal to plus or minus the square root. I might need a little more room here. The square root of 1 minus cosine theta over 2. All right, and then the value of plus or minus will kind of depend on where our angle falls, and we'll get into that in just a minute. Okay, so what we can do is we can simply just apply this formula and then replace theta with pi over 6. So we have plus or minus square root, and then we have 1 minus cosine pi over 6 over 2. And now I can look to a unit circle. Let me pull that up really quick. Cosine of pi over 6, that's an x value, and that is going to be specifically 1 minus root 3 over 2 over 2. Okay. Now let's try and simplify this a little further. Let me sort of take a detour and look directly at 1 minus root 3 over 2. We want to find a common denominator, so I can turn 1 into 2 over 2 and subtract these. And then I will get 2 minus root 3 over 2. And then again, by the same rule we had before, we can multiply those denominators together, and we will get the square root of 2 minus root 3 over 4. Now, we can actually apply the square root to the numerator and denominator individually. So what we can get now is we have this plus or minus, and then we have the square root of 2 minus the square root of 3, and then the square root of 4 on the denominator, but the square root of 4, of course, is just 2, and so that just becomes 2. Okay, so that was the whole simplification process. Now let's look to our plus and minus. Keep in mind that we were working with pi over 6 as our angle theta, or pi over 12, either one. And if we look on a unit circle, or if I just draw a unit circle, this is going to be about right here. And all we're really getting at is this is in the positive y direction. So I would expect the output of sine, which is a y value, to be positive. So I know specifically in this case that this is a positive root 2 in that whole mess. And so the final answer is that sine of pi over 12 equals the square root 2 minus root 3 over 2. And that is a way to find the value of a trig function where the angle theta is not on the unit circle.